Okay, this is another topic for applicable electric materials in the preparation of architecture buildings. Still, we have the same learning outcomes. We have to name the common electrical terminologies and define electrical concepts and materials for designing the system. Now let's proceed. So still the overview, we are now discussing about the wires and cables. We are done with the conductors and insulators. So we are now proceeding to the wiring and raceway method. So we are done with the first two. Okay, this is an overview diagram for lighting, motor, and controls. Now, since we are done already with the wiring and raceways, we will now discuss about the utilization of equipment. Then, the next one is the power handling equipment. Now, in types of lighting, so we have many options exist for providing light in a home, from integrated architectural solutions that require contractors and tradesmen to decorative lamps that need only be placed on a table and plugged into the nearest outlet. So we will now discuss the different types of lighting. Remember that the first common lighting in the Philippines is the architecture lighting. Okay, we have the three most common forms of architecture lighting, and these are cove, soffit, and valance. Okay, all three are integrated into the room structure. So architectural lighting is most often used as ambient lighting. Okay, we'll now discuss the first architectural lighting, which is the cove lighting. So as you can see in the background, cove lighting is in a ledge, shelf, or recess high up on a wall, and the light is bounced toward the ceiling or upper wall. And the next one is common on some commercial buildings or some coffee shop. So they are applying the soffit lighting, where it is corniced near the ceiling and the light radiates downward, washing the wall with the light. The third one is commonly applied on wood, metal, or glass valence. Okay? So still, the application is the light will bounce both upward and downward. This is the valance lighting. Okay, aside from the architectural lighting, we'll now proceed to the recessed lighting. Okay? So recessed lighting is common on residential and office. So it is installed above the ceiling. Okay, this type of lighting has an opening that is flush with the ceiling. That is why some recessed lighting, commonly called flush-mounted lights. Okay? A recessed light requires at least 6 inches of clearance above the ceiling, and insulation is essential to ensure that condensation does not drip into the fixture. Now for track lighting, used commonly on exhibits and some product presentation. So this is mounted or suspended from the ceiling. So track lighting consists of a linear housing. So that is why they are positioned to focus on your product or focus on an item for track lighting. Then the next one is the under cabinet lighting. So as you can see, so this is similar for cove lighting, where light will bounce on the wall. So mounted under kitchen cabinets. The next one is the pendant lighting. And the keyword for pendant lighting is suspended luminaires or suspended fixtures. Okay, a pendant can enhance the decorative style, commonly on kitchen. Now, we already discussed about the types of lighting. How about the lighting fixtures? We have many lighting fixtures that can be applied on some buildings, residential or commercial. And the first one is the chandelier. Okay, this is suspended from the ceiling and it is under with the suspended lighting, which is pendant lighting. The next one is the ceiling. This type of fixture is mounted directly to the ceiling and has a glass or plastic shade concealing the light bulb. Aside from the wall lamp, it is also called wall sconces. Okay, provides ambient or task lighting also. Okay, some of the coffee shops, some of site development, uh, they are applying or they are using wall sconces. Okay, next one is the desk, floor, and table lamps. It is made in a wide range of sizes and styles. Lamps are extremely versatile and portable sources of light in a room. So if you are using these desk, floor, and table lamps, this is a direct light downward application. Now, uh, I will present the diagram or illustration on how to use different bulbs on recessed lighting. In this left side, okay, in this left side, we have I think we have 5 recessed lights where you have baffle, open, reflectors, eyeballs, and lens. Remember that each recessed fixture has different bulb styles that you can use. So for baffles, you will use par bulbs, while for open style, you will use another par bulbs which is in this shape. Okay, so these are 4 bulb styles that you can use for recessed lighting and for better lighting style. In this right side, this is the application of different lighting fixtures. So remember that you cannot use a wall sconce on a ceiling. That's a clear common sense. So task lighting, under cabinet lighting, indirect pendant where the light bounces to the ceiling before it goes to the direct or the target lighting area. Well, the direct pendant is on the direct area. Okay, recessed fluorescent, recessed can, and wall wash. Okay, wall wash is applicable for ceiling while wall sconce is applicable for all adjacent wall. Now remember that you are not applying light fixtures or illumination on a certain office without recommended light level. Under electrical engineering, we are solving the proper light or light level for an area. So it is called illuminance. It is a total luminous flux incident on a surface per unit area. The surface is your target area where your light will be applied. Okay, the area is the work plane, the room, or space are performed. So this is the formula. We have E equals light intensity, which is measured by lumens per meter squared, or lux. Okay, another name for the unit. So the symbol for this is the luminous flux and the area. So measuring units, we have different units under the imperial system and the SI system. So for imperial system, we are using foot candle, while in the metric SI system, we are using lux. Okay, they are the same. They are units light level, but in different system. So please refer on this converting factors. So only electrical engineers know how to solve this and know what is the method of solving the target area. Now, this is the recommended light level, which is outdoor light levels or natural lighting. Remember, since we are in the Philippines, we are commonly use lux. So from sunlight to overcast night, in this right side, we are referring lux. So you have 107,527 for sunlight. Full daylight is 10,752. Overcast day, 1,075. As an architecture student, this is your guide on using the natural lighting in your building. Okay, the next one is, if we have with the natural lighting, we'll have a recommended light level for every area, space, or activity. In public areas with dark surroundings, we have only required 20 to 50 lux. Simple orientation for short visits is 50 to 100. Now let's refer to the home. So we have warehouse and home theaters, 150. For office work, we have 250. Okay, you can use this reference for your lighting and lighting of workplace, indoor workplace recommended light level. For classroom, we are required to have 300 lux. Now, the short review, calculating illumination. Earlier, we just only considered the flux, rather, we'll go back to the luminous flux, the quantity of lighting needed by the light source, but for greater derivation of the formula, so we come up with, aside from the illumination, we consider now the luminance per lamp. Okay, the coefficient of utilization of lamp and light loss factor. So this is now, we use the factor of your lighting fixtures. For example, so you have 10 incandescent lamps of 500 watts, 10,600 lumens per lamp. Assume that this 500 watts has a 2,600 lumens. Lumens represents the lighting intensity of the lamp. So that is used for 50 meters square with your coefficient of utilization is 0.6, which is the perfect is 1, and the light loss factor is 0.8. So it can be calculated now. In solving the illumination, you have 1018 lux in your area. So another term is luminance. And luminance is the only basic lighting parameter that is perceived by the eye. Okay, that is perceived by the eye. Okay. So in our language, we are referring it as hayag, kahayag, or kasiga. Okay, describes the one hand or the light source impression of brightness. Then the light levels in buildings. So we already know the difference between the foot candle and lux. They're just in different system. So the most cited reference for lighting levels is the IES and a lighting handbook, which is published by the Illuminating Engineering Society. So since we are concerned mainly with accomplishing tasks in our buildings, we need to understand the illuminance, or the amount of light that is hitting a surface. So in an office, we might want to understand the amount of light that is hitting our desk. However, in a gymnasium or corridor, we may be more interested in the amount of light hitting the floor. This is the two different application of illumination. Okay? So illuminance is measured in foot candles or lux. So what foot candle is the amount of light that hits a 1 square foot. So this is purely an English system. So 1 lux is the amount of light that hits a 1 square meter of a pure SI system. Okay? So this equates to 1 lumen per square meter. Remember that hits a 1 square when 1 lumen is shine from 1 meter away. This equates to 1 lumen per square meter. So 10 lux is roughly 1 foot candle. I've already discussed about the recommended light levels by space, but using the table under IES and A lighting handbooks, which is updated for IECC 2021, or using the space by space method for calculations under electrical engineering. So cafeteria, so 200 to 300 lux. I consider this table because under architecture course, you are designing the interior of a structure or building. So I attach the light level recommended and also the watts per square foot. Okay, so you're the one will convert it into square meter. Okay, another one is for the loading dock. This is for industrial part. Mechanical electrical room is 200 to 500 lux. So this is common na ma-defeat ang purpose sa mechanical and electrical room because some architects just put one bulb only. But in reality, the light level lux is 200 to 500 lux. Okay, it is almost, it is lighter than the locker room, lighter than, same as brightness in the office. Now we are already done with the recommended light levels, lighting fixtures. We will now proceed to the switching and overcurrent devices. Okay, devices for lighting purposes also. So, okay. Okay, what is switch? Switch is a device which is designed to interrupt the current flow in a circuit. Okay, we're already familiar with this with our theory, which is discussed in week 1. So we have this simple circuit. We have switch open. So automatic lamp is off. If the switch is open, lamp is off. And your source is battery. So if your switch is closed, the lamp is on. Okay. Now the characteristics of a switch. So I will read the two important characteristics of which are its poles and throws. So in the market, you are not using just say to the sales representative with I will buy a switch. But remember the two important characteristics in buying switch is poles and throws. So a pole represents a contact and a throw represents a contact to contact connection. So number of poles and throws are used to describe a switch. So some standard numbers of poles and throws are single pole, one pole or one throw, and double, two poles or two throw. Okay, this is an incorrect type. So if the number of poles or throws are greater than 2, then the number is often directly used. For example, 3 pole 6 throw switch is often represented as 3P60. This is the code. Okay. Let's proceed to the type of switches. So basically, we have two switches. We have mechanical and electronic. Mechanical switches are physical switches which must be activated physically by moving, pressing, releasing, or touching its contact. And it is common on residential and also in commercial buildings. While electronic switches, on the other hand, do not require any physical contact. So in order to control a circuit, these are activated by semiconductor action. So this is some mechanical switches commonly on electronics. So be familiar with the method of activation. You have manual, limit and process switches, the number of contacts, the number of poles and throws. So we have SPST, DPDT, and SPDT. We will discuss this in the next slide. So SPSCT, which is single pole, single throw switch, and the most common one. Okay, single pole. This is the basic on and off switch consisting of one input contact and one output contact. The next one is the single pole double throw switch. A single pole, one, they are single pole and double throw, 1 and 2. This switch has 3 terminals. One is input contact and remaining 2 are output contacts. This means it consists 2 on options and 1 off position. The next one is double pole single throw switch. Okay, so double pole 1 and 2, single throw 1 and 1. So this switch consists of 4 terminals, 2 input contacts and 2 output contacts. So as you can see, we have 2 double throw single throw. So you can switch here to light up the lamp. You can switch here to light up the other lamp. So another application, if you are using lamp and motor, so this is applicable. So it behaves like a 2 separate SPST configuration at the same time. Okay. The next one is the double pole, double throw switch. Okay, it behaves like also a two separate single pole, double throw configuration. So as you can see, single pole, a double pole, one pole, two pole, then double switch, one and two. So commonly used in some motor applications. The common one switch is the push button switch. So this button returns its normal position once the pressure is removed. So that is why in electrical engineering, so we are using the normally open and normally closed. So apply pressure, it will remain as normally closed. Another apply pressure, it will normally open. So toggle switch. So this is in electronics application. The next one is the limit switch. So the control schemes of limit switch are shown in this figure. We have normally open limit switch. So this is a limiter, and some is you can see this on car or also in motorcycle parts. So these switches consist of bumper type of arm actuated by an object. Next one is the float switches. This is used on water in a tank or sump. Okay, normally open, normally close. Commonly for tank if it is water tank application. Next one is the flow switches. So these are mainly used to detect movement of liquid or airflow through a pipe or duct. So the airflow switch is constructed by a snap action. So the figure show the switch symbol used for both airflow and liquid flow. Pressure switches. Okay. In all these types, pressure detection elements operates a set of contacts which can be either double pole or single pole contacts. So this switch symbol consists a half circle connected to a line which the flat part indicates the diaphragm. So these switches may be either normally open or normally closed type configurations. So types of switches according to the type of service. Remember that we discussed the different kinds of switch, but we have three types of switch. The first one is the service switch, which is intended to disconnect all the electric service, and this is commonly on circuit breaker, panel boards, and disconnecting leads. The next one is the power switches. The power switches is the general purpose switches, which are intended for use in general distribution and branch circuits, while the disconnecting or isolating switch are intended for disconnecting or isolating circuits used for circuits rated at more than 600 volts. Now, this is the power switches. The next one is the service switches. But in the industry, service switch is the main switch. That's what we refer main switch. Now, power switch is what we refer panel board or circuit breakers. The wiring switch, this is what we discussed earlier, or the general purpose switch, the single pole or double pole. The three-way switch is the different kind of wiring. And the four-way switch is also under the different wiring of lighting. As we have four types of electric switch is the single pole switch, which is already discussed. This is just a purpose of on and off. The three-way switch are always used in pairs. Okay, this is three-way switch. And allow you to control light or receptacle from two different locations. So this is you can apply it if you are in the stair, then the second floor, then you have two different switches controlling one bulb or one lamp. So this is the diagram. So the name three-way at the first glance is a little confusing. Three-way. The term refers to the fact that there are three different ways to switch. Okay, 1, 2, and 3. So both toggle levers up, both toggle levers down, or the toggle levers in opposite position. Okay? So if this line toggle you to this to down, no circuit or the lamp will still shut off. If you toggle this on, then in this part is your toggle off, but still there's a circuit, complete circuit flow, so still it is on. So remember that the circuit is a closed loop. So even though this is a hot in the red color, it represents that there's a circuit flow. If this part toggles below and this part toggles also at down part, then there's also a complete circuit. Okay, when both toggles are up, so I already discussed that. So this is the application of three-way switch. So if you are below downstairs and there's another switch for at the top. And this application can be seen commonly on emergency exit or any stairway or staircase application. Other than the three-way, there's a four-way switch. It is used between two three-way switches. Okay, we have three-way, another three-way, then you will buy another four-way. So commonly you will use three switches, but two three-way and four-way. Okay, if you want to have control from more than 3 locations, for example 5 locations, you would still use two three-way switches. So this is 2 or more location application, and you will now apply the four-way switch. Okay, this is a simple diagram of the four-way switch. So four-way switches are used to control lighting from 3 or more locations. 1, 2, and 3. Four-way switches are used in combination with three-way switches. These are 4 terminals that provide 2 sets of toggle positions on a four-way switch. So each set of terminals is one of the toggle positions. When the switch is in the up position, the current can flow through the 2 terminals. In the down position, the current flows through the other 2 terminals. There's another alternative way of circuit. So the different switch fixture, and this is highly applicable for architectural use. So the common one is the toggle switch. Toggle switch or the common light switch that just about everyone has in their homes. So these light switches are placed in just about every room of most people's houses, and they are easy to install. So you won't have any issues trying to figure out how a simple toggle light switch works. These are some toggle light switches that will come with special features, though this one here is actually capable of interfacing with your smartphone. Okay, this one in the picture. You can set up timers to turn the light on at a specific time, and can even simply activate it without having to get up from your seat. So it even has a full integration with Alexa or any smart AI application, making it a truly convenient option. So if you want something less technological, then you can purchase a standard toggle light switch instead. So you will be able to find the normal toggle light switches at just about any hardware store that you can think of. So installation should go smoothly, and you'll have the reliable light switch that you need. Next one is the push button light switch. Okay, push button light switches are probably the second most common light switch that you can make use of. They are simple switches that will work excellently in your home. So you often see these types of switches in people's bathrooms. So sometimes they are wired to both the lighting and some types of an exhaust fan. Okay, it's commonly in CR comfort rooms. There are some variations among these push button light switches too. Some of them are designed so that when you press the button, it will stay recessed until you press it again. So there are also models that have you press the button and it will return to the normal position. So which type of press button light switch you prefer will really come down to personal preference. So as an architect or architect soon. So some people prefer the switches that stay recessed because it gives them a visual cue of what position or mode the light is currently in. So this can inform you when something is wrong if your light is supposed to be on, but it isn't coming on. So it can help you realize that you need to change a bulb or fix some type of wiring issues. And that switch is if you normally there's a signal or another signal reference. Okay. So the push button light switch being shown off here is a nice and simple single button button. It does have the convenient feature of having a blue LED light installed inside. So this helps you to know when the light is in the on position. So it makes things really simple. So this is definitely a good light switch to buy. Next one is the proximity light switch. The proximity light switches are very useful to set up in your home. So when you want to cut down on wasting energy. So these switches can turn a light on in your house when you are in a room. So when no people are in the room any longer, the light switch will shut things off. This makes it easy to save energy. And you won't have to bother searching for the light switch when you're entering the room. So this is under intelligent buildings category. So environmental concerns are on the minds of many people in modern times. So being able to cut down energy consumption, it is a very appealing prospect. Okay, you might wind up saving some minor amount of money on your monthly energy bills if you make use of this type of light switch. Unless you are a very wasteful person, when it comes to energy, it is unlikely that you will see a substantial difference. Next one is the selector switch. A selector switch can be very important when you're trying to set up lighting that has two different modes, just like Christmas lights. So the selector switch is going to allow you to switch between two different settings effectively. But commonly, there's a higher application of lighting fixtures where in a one bulb you can have three different light outputs. You have warm white, daylight, and cool light. And it belongs to the selector light switch. The selector switch is going to allow you to switch between two different settings effectively. So these type of switches are actually commonly used for fans, switch fan speeds, and also fan modes. When it comes to lighting, this can allow you to select from different lighting modes. Sometimes people use these types of switches when they have lighting setups that have different colored lights, which is I discussed earlier. So it lets them select which one they would like to use at any given time. So it is pretty easy solution to setting up your lights, and you will find these types of light switches being used in many places. So the most typical type of selector light switch is the rotary switch. It sort of functions like a dial that allows you to switch between different modes. The next one is the dimmer light switch, and applied mostly in hotels, apartments, and some restaurants. So you will find that there are times when you want to have just a little bit of light to set the proper mood. Some people refer to dim lights as mood lighting, and other think of the lights as romantic. So to be able to dim your lights effectively, you are going to need to have some type of dimmer light switch. So thankfully, these light switches are actually very common and pretty simple to set up. But remember, take note, not all bulbs are compatible with dimmer light switch. Please use bulbs which is compatible for dimmer options. Okay. Next one is the photo light switch. Photoelectric light switch aren't as commonly used in homes. They're not common as much as the others that are on the list. Regardless, this type of light switch is very useful and will have some application that you will be able to make use of. So if you want to be able to set up light that will automatically come on when it starts to get dark, then you will need to make use of photoelectric light switch. So it is a sensor, commonly in street lightings and also in garden lightings. So the next one is the motion activated light switch. There's a good chance that you have seen motion activated light switches before. See, if you ever walk up to someone's property and seen the porch light automatically come on, then what you encountered was a motion activated light switches. So many people decided to set up motion activated lights in their yard. This can keep people from sticking around on your property during the night. So the sudden activation of a light is usually enough to scare any would-be intruders away. The next one is the sound-activated light switches. Sometimes people seek out light switches that are more convenient to use. So when you want to able to use light switch without having to get up to press or flick the switch, your options are going to be limited. So in this picture, they are using a sound effects or in a clap motion. So motion activated switches are out there, but these are more commonly used for outdoor purposes only. Now we are already done with the switches. Now let's proceed to the wiring devices or under the power devices. Okay? So this we have the outlets and receptacles. Outlets and receptacles are common terms. They are same terms in different jargons of professionals. Outlet is a point in the wiring system at which current is taken to supply utilization equipment. For electrical engineers, we are referring this as receptacle. For common people, we are referring this as an outlet. So it refers only to the box. Okay? Box only. That is an outlet. A receptacle is the wiring device in which the utilization equipment cord is plugged in. Outlet will be receptacle if there's a utilization of the equipment. Okay? Kinds of outlet. So convenience outlet or attachment cap. This is common. So lighting outlet intended for direct connection to a lamp holder. Then receptacle outlet where one more receptacles are installed. Other wiring accessories, junction box. It is an enclosure where there's connections and wiring terminations. Sometimes it has a PVC material. Some of them are steel material, metallic material. So it protects the connection and provides safety barriers of wires. Another one is the pull box. Pull box is commonly on, you can see in the parking space of a building where large wires like this in the lower right. It is a box with a blank cover that is inserted in one or more runs or raceways. So there's a certain angle to maintain the curve of wires or to have allowance for wires for cable pulling application. So these are the wiring devices in the electrical application. So earlier we discussed about the branch circuit, and we have also a branch circuit protection. And in this diagram we have a panel board, 200 main, and numbers of circuit breakers. We have inverter, then another disconnecting means, and meter. On the right side is a circuit breakers. Overcurrent protection devices are meant to protect against the potentially dangerous effects of overcurrent. So something as simple as a circuit breaker can protect against this damage. But if a fuse or circuit breaker doesn't have an adequate voltage rating, it can rupture or explode while attempting to stop fault currents beyond their interrupting ratings. So grounding helps to protect against inadequate overcurrent protection or OCPD failure. So the two processes are designed to work together to protect equipment, property, and people. What are overcurrent protection devices? So to have a properly operating circuit, current flow should be confined to a safe level. So under normal operating conditions, the current in a circuit should be equal to or less than the normal current level. However, times an electric circuit may have a higher than normal current flow, which is also referred as overcurrent. So what is overcurrent? We already discussed about that. Now, we have a difference with the other one, the short circuit. With the short circuit situation, the current takes a shortcut around the normal path of the current flow. However, with the dead short, the resistance of the load will be completely removed from the normally current path. So, this is common reasons of wires short circuit. So, we must have a very careful on installation wires, wiring wires, termination of wires in the building. So, to avoid short circuit. While the overcurrent, to avoid this is the electrician or the electrical project manager or electrical project site engineer must follow the computation in the plans. Okay, this is a schematic diagram. So the first one is the pictorial drawing where you can see the short. So from the voltage source to switch, where the electron flows or the current flows, goes to the load lamp, then there's a partial short. Okay, in this schematic diagram you can see instead of flowing it straightly, there's a bypass here where instead it will pass through straight to the light bulb. It has another bypass path and it results into the short circuit system. Okay, so if the source has enough stored energy when a dead short occurs, circuit components can be damaged or explode. So there's a explosion, and that is a dead short. Switches can melt or vaporize, so conductors can overheat, and the insulation can burn off. And it results to fires. So with so much at stake, all circuit must be protected against short circuit situations. The third one problem is an overcurrent condition, which is overloads. For example, consider a situation where too many loads, just like in the illustration above, are connected to a given power source. So let's have an illustration. What is an overload? Okay, this is an overloaded circuit. You have 15 ampere circuit breaker branch circuit. In this case, the rated current capacity of the branch is 15 amperes. However, if you sum up all the currents drawn by this load, parallel loads, you have 3 amperes, 2 amperes, and 12 amperes. So, if you sum up this, it is already 17 amperes. So, the circuit is overloaded by 2 amperes and as a result, the breaker trips. Okay, this is an analogy of overloading. Overcurrent protection circuit is the resistance of a fuse or circuit breaker is very low and usually an insignificant part of the total circuit resistance. In general, these overcurrent devices must be installed at the point where the conductors being protected receive its power. For example, at the beginning of a branch circuit, in the event of an overcurrent situation, fuses will blow or circuit breakers will trip. All these devices protect the circuit against overcurrent conditions. Branch circuit, OCPD, which is overcurrent protection device. Okay. They are not normally capable of correcting the problem. Remember, they are not normally capable of correcting the problem. For this reason, you will need to locate and correct the problem before replacing a fuse or resetting a circuit breaker. Protection devices. So in this, protection is assured via detaching power supply, and it is overcurrent protection. To point out, Various protection devices act as protection agent and prevent us from many electrical damages. Generally, these devices remove fire hazards and electrocution. Usually, this protection is from extreme voltage or current. To mention, circuit protections are the electrical devices that prevents the devices from the flow of unnecessary currents as well as the short currents. So these are the types of circuit protection devices. The first one is the circuit breakers. Can be found in the following applications. Unlike a fuse, which has a similar function, circuit breakers can be reset and reused to resume normal operations. So they are made in varying sizes, including small devices that protect low current circuits on household appliances to large switchgear that can protect higher voltage circuits. Okay, so we have three basic circuit breakers variety. The first one is the standard breakers, which is both single pole and double pole circuit breakers. The second one is ground fault circuit interrupter circuit breakers, which is applicable on some kitchen and wet area. The third one is the arc fault circuit interrupter circuit breakers, and it is highly used in the industry. First one is the single pole circuit breakers. Okay, the most often found in the homes today. So they are named single pole because they are designed to monitor the current of a single wire only and trip in the event of a short or electrical overload. Okay, next one is the double pole. So monitor two wires simultaneously. Next one is the GFCI breakers. So they are designed to protect against a line to ground fault. These breakers are required by some electrical codes for areas in the homes that can become wet, such as bathrooms, laundry rooms, and outdoor areas. Next one is the AFCI circuit breakers. They are designed to trip when arcing is detected within electrical wiring. Okay, this occurs when electrical cords becomes damaged or its coating becomes too thin and it represents a serious risk of fire. Okay, so standard single pole and double pole won't always detect electrical. Take note with that. The standard single pole and the double pole circuit breakers won't always detect electrical arcs because they are only tripped by excessive heat, while the AFCI circuit breakers are required as a part of electrical code on newer houses. Fuses. In the old style of electrical installation, instead of using circuit breakers, some old homes are using fuses. But now fuses are highly used on some electronic applications, just like laptops and so forth. Okay, so like this is the illustration of fuses. Now let's go to the utilization of equipment or the power equipment, and this is transformers. Okay, you can see it alongside the road, power pole. So we have distribution transformer under the double light. Measurement transformer, you can see it in the substation. Power transformer, you can see it on some of hospitals and large commercial or institutions. Let's proceed with the residential transformer. This is the common one. So this is a single phase pad mount transformer, which is they convert electricity, but primarily they convert voltage from 7,200 volts or 18,200 volts to 120 or 240 volts. 240 volts commonly used in the Philippines. So transformer in commercial buildings, there are 6 types are normally used in commercial buildings. So remember that these transformers are in need of a large area or large space in your vicinity. So we have substation, primary unit substation, secondary unit substation, network, pad mounted indoor distribution. These transformers are highly applicable reference such as welding constant voltage supply, and also if you have certain vast area or wide area application, where just like an example for Azuela Cove, that is a large area power application. So you need a substation transformers, and also you have a substation area. Next one is the primary unit substation transformers. The next one is the secondary unit substation transformers, which is used and it is also housed. Next one is the pad mounted. Can be put outside of the building since this is covered up. For use outside the convention, unit substations might not be appropriate. If you don't need substation. So it either single phase or three phase units. Aside from the transformers, commercial buildings need an automatic or manual transfer switch. So transfer switch is a device that automatically, manually transfers a power supply from its primary source to a backup source. Remember that the backup source in the industry is the generator. Okay? So that is why we have automatic manual transfer switch. When the first one, which is connected to the double light, trips off or have a brownout or a blackout, it will automatically transfer switch to turn on the generator to provide power source to the establishment. Okay? So an ATS or NTS can also start up more long-term backup power systems such as local diesel generators to run electric equipment until utility power is restored. The next component for electrical system installation is the panel board, which divides an electrical power feed into a branch circuit. Okay, the later part of this week, we will discuss the branch circuit, while providing a protective circuit breaker or fuse for each circuit in a common enclosure. Now, what is the difference between a switchboard and a panel board? So, switchboards and panel boards provide a similarly functionality and power distribution system. But remember that the panel boards are typically flush mounted, meaning it can be installed outside of the wall or surface mounted embedded in the wall, and are limited to a maximum of 1,200 amperes incoming current. So this is just only a limitation of the panel board. While the switchboards are freestanding units that are front connected, and like panel boards required only front access. Okay, you can access the switchboards front and back. And it contains bus bar. So switchboards can contain busing and overcurrent devices up to 5,000 amperes. So we are already done with the wiring devices and everything under the utilization of equipment. Thank you.